Welcome back to the next in our pathogen murder mystery series. This episode is going to be about annotation. So let's just step through where we've gotten to so far. We sequenced the mystery pathogen that's spreading across Europe. We looked at the reads because it's important to make sure that the first step in your analysis, that the data is good. And so we analyzed the reads using FastQC and they looked pretty good. We submitted the reads to a taxonomy pipeline and it identified them strongly as Enterobacteriaceae, which is the family that includes E. coli, and we could even see that it was hitting E. coli on that graph. We did a serotyping pipeline, and that showed that the pathogen was O104H4. This was not typical of the circulating E. coli strains that contained Shiga toxin in Europe at the time. And in the last two episodes, we assembled our mystery pathogen. And so now we're going to annotate it. And so you may ask, what is annotation? Well, an annotation is putting the genes and identifying the genes that are on those contigs that we assembled. So it's just showing the location of those genes and where they start and where they stop. But it's also showing the function and predicting what they do. So you can ask, why bother with annotation? Well, I like annotation, first of all, but mostly it's because our mystery pathogen is something new. We don't know what it is, but you may say, we do know what it is. It's E. coli. It's serotype 0104H4. We even know that it has the Shiga toxin gene. That's all we need to know. It might have a lot of other stuff too that we need to look at. And also, when we're going through these things, especially for building trees and things like this, the annotation is really going to help with that. So just so you can think about it, here on the left panel is the assembly, where you just have a long string of DNA nucleotides. On the right, this is an actual schematic of the pathogen from the 2011 outbreak in Europe. And it's showing you where those genes are on the organism. H4 in the flagella. Remember, 0104 is on the surface of the bacterium. And here is STX2, that's that Shiga toxin gene, and it's showing that it's right here on the bacterial chromosome. But when you annotate it, you can see that there are a lot of other things in there that are important virulence factors that we need to know about. So the pipeline that we're going to use today is called RAST-TK. And once again, we're going to go back to the Bacterial and Viral Bioinformatics Resource Center. It's really easy to use. And when we submit our contigs there, it'll call RNA, it'll call some other stuff, CRISPR elements, but this is where it's calling the genes that are protein coding genes and the start and stop of that. And then it's going to start hanging functions on those genes. And then I wanted to point this out in particular. Another part of this pipeline is it blasts it against known databases of proteins that contain things that we're interested in. Antimicrobial resistance genes, virulence factors, and other stuff. So that's what this pipeline brings to you too, is that you can see genes of interest. So this is what it looks like at BVBRC, and we're going to go in right now and generate this annotation. So we go up here into Tools and Services, and we click on Genome Annotation. Now, you've seen me go to the workspace, but I've already generated contigs, and I could just put in the mystery. See, I even started, and it knows what I'm thinking. Searching through that huge workspace I had and looking for things that match the text I put in. I'll say it's that one. And then the annotation recipe it needs. At this resource, you can annotate either bacterial or archaeal genomes, some viruses, and all bacteriophages. Well, we know that this is Escherichia coli, so I'm going to use the bacteria annotation pipeline. Then we need a taxonomy. And like I said, it's Escherichia. Now I could just put in Escherichia, but we also know that it's coli. So I click on that and it also fills in the taxonomy ID because it wants you to tell it what it is. That's why we went through taxonomic identification using both reads and contigs so that we could tell the pipeline, we want you to look in this particular area for this taxonomy. And now I need an identifier, a mystery pathogen example. And for the output folder, I just start typing it and it was the pathogen murder mystery. Now you all know when I push this annotation button, I'm going to get a notice saying that that annotation has been submitted. I've annotated this several times. So I don't want any more in my workspace. But let's go to the jobs and you can see the one I did just before this with the same reads. So I'm going to click on jobs here. And then we can see this annotation right here, our mystery pathogens. So I can highlight the row and then I would click the view icon. And this is giving me everything I need to know about this particular annotation. And it's just file upon file upon file if one wants that. And also you can look at the quality of the file here. But what I really want to show you, what I want to convince you of is why you should use this thing other than the fact that it's really easy is it gives you great ways to view the data. Also, this genome, which is my private data, and if you weren't looking at my screen and you were logged in, you could never see it. That is in the resource. So I can use it to make trees and things like that. I can include it in those things where I can't if it's outside of the resource. So to see the page about that genome, I'm going to click here on this view icon, and it's opening up a page for my mystery pathogen, and it's telling me information about the taxonomy, the status. Look, it's calling the MOST. So we talked about the multi-locus sequence typing way back in the first or second episode of the series, and a lot of researchers use this to identify a pathogen. This pipeline automatically calls it. So it's telling you how many genes there are, what kind of genes there are, but I want to point you to this part. It is also calling virulence factors, drug targets, and antimicrobial resistance genes. But remember, I told you that when it's going through the pipeline, it takes all the proteins in that genome and does a blast analysis against these specialty databases. This one's a very well-known database, the virulence factor database. So I can click on this, or I could go up here to specialty genes and click on that. Well, let's click on this to see what proteins in our mystery pathogen genome had strong homology to proteins in the virulence factor database. So I click on that and it opens a new tab with that. And it says there were 83 results. And as you've seen before, when I've navigated through my workspace, you can click on any column head and it'll resort the things in alphabetical or numerical order, depending upon what you want. And so I just want to scroll through here. And these are all things that are virulence factors. Before we only knew about the Shiga toxin, but look, here are the two subunits of Shiga toxin 2, which we already knew about, but here it is. But also in this annotation, we can see a lot of other things that are known as being important in virulence for these organisms. So that's a good reason to do an annotation, and the ease and the ability to see it here and have it integrated into the resource so that you can do downstream things like build phylogenetic trees, which we're going to do next time. That's another reason to annotate it at this particular resource. So the next episode, we are going to start generating our trees. I hope you'll join us because that really is my favorite part. I do trees for everything, and I think that you'll like it, and I think it'll be an interesting thing for you to see. So thanks for coming, and I'll see you next time.